In this assessment, we're asked to predict the product of the elimination reaction shown. I've gone ahead and shown the two possible products on screen. It will be one of these that's going to form, kind of just to speed things along. The other thing that we'll kind of jump to is because we're using a strong base, this is going to be a reaction that proceeds by the E2 mechanism. And so how do we pick which of these two products is going to form, because only one is going to happen? Well, the way we're going to do that is we're going to make sure that we follow the rules of E2 elimination, which says that the hydrogen that gets removed must be anti and coplanar to the leaving group. And so that's going to require us to draw Newman projections. What we'll do is we'll start by drawing a Newman projection looking down this bond here. We'll note that if I put my head in that plane, this methyl group is going to be closer to my chin in the plane. And so we would end up, what we're going to see is the following. The phenyl group will be over here on the right. The hydrogen not shown in the molecule will be here on the left. And I'm going to go ahead and label this as a CH3. If we look to the bond in the back, so we can draw our circle in our Newman projection here, we'll see that the 3-carbon propyl group, I'll just abbreviate it as PR to show that that's the propyl group in the back in the same plane as this CH3. The chlorine is going to be over here on the right, and the hydrogen will be on the left. Now, we kind of got lucky in this because the Newman projection that we drew initially has the proton and the chlorine anti and coplanar. And so we can imagine our E2 mechanism where the proton gets removed, the electrons bounce back, kick out the chloride leaving group. All of this, we don't need to really talk about the E2 mechanism, except that what this shows is that in our product with the anti and coplanar proton and Cl-, the propyl group and the phenyl group are on the same side of the molecule. That's only going to be true in this alkene here, the phenyl group and the propyl group on the same side of the alkene. So this is the product of our reaction. Just to review, once we identify the conformation that gives the anti and coplanar proton and leaving group, we look at the side that the substituents, if they're on the same side in that Newman projection, they'll be on the same side in the product.